4-8 complex numbers. Complex numbers deal with what do they call an imaginary unit or an I factor. So what they're talking about is I is equal to the square root of -1. And then right there where they're talking, I squared equals -1. Why? Because I equals square root of -1, so the square of it equals -1, and so on and so forth. So how do you take the square root of a negative number? Well, again, it's just square root of -1 times a, which gives me I radical a. So how do you write the square root of -18, I'm sorry. What you do is, again, the minute you see a negative underneath the radical, write an I out front. So you turn this into the I, the square root of 18. Again, it comes down to what perfect square goes into 18. You end up with the square root of 9 times square root of 2, and that gives me 3I radical 2. Complex numbers are made up of a real part, which they have a, and an imaginary part, which is bi. Okay, and here's some rules to deal with that stuff. But again, all you have to know is that a plus bi for imaginary numbers. And they act kind of like everything else that we've done with combine like terms. So what's 4 plus -4? Well, 0. And then -3i plus 3i is also 0, so our answer here is 0. What about if I gave you 5 minus 3 minus -2 plus 4i? Now, I would take and distribute my negative sign through here. It makes it easier. So 5 plus 2 is 7, plus, and then -3i plus -4i gives me -7i. So our answer here should be 7 minus 7i. Let's say you add. What about multiplying? No difference, distribute through. So 3i times -5 is 15i. -15i. Okay, 3i times 2i, numbers with numbers, so that gives me 6. I with I, which gives me I squared. Now, we talked about I squared equaling -1. Okay, so what we end up doing here then is getting -15i minus 6. And how you should write that is -6 minus 15i should be your answer. That's called a complex number. Here's where the fun starts, dividing complex numbers. So what is each quotient? So again, you can't divide by this, and I can't do 9 divided by 3i. That doesn't work. So I got to get rid of the i's and denominators, just like you have to get rid of radicals and denominators. Why? Because I is the square root of -1. So let's multiply top and bottom by 3i. And you technically want to do the complex conjugate, so you have to multiply by -3i. And when you do it on top, you got to do the bottom. What do I end up with there? Well, that gives me -27i minus 36i squared all over -9i squared. Now, what is I squared? Again, I squared is -1, so I end up with the negative of -36. So I get -27i plus 36 over, and again, I squared is -1, positive 9. Let's clean this up a little bit. Start with the number. 36 divided by 9 is 4, minus 27 divided by 9 is 3i. Okay. Now here, the complex conjugate of 1 minus 4i is 1 plus 4i. So I want to multiply top and bottom by 1 plus 4i, and then 1 plus 4i. So what I'm doing now is I'm going to go ahead and FOIL this stuff. Okay, so first is 2, outer is 8i, inner is 3i, last is 12i squared. over, now let's FOIL the bottom. 1 times 1 is 1. That's the first. Outer 1 negative and 4 is positive 4i. Inner negative 4i times 1 is negative 4i. That's the reason why you use complex conjugates, because of that right there. And then minus 16i squared. So let's clean this up. Top, combine like terms. Remember, I squared is negative 1, so that just becomes a negative 12. So you get 2 minus 12. 2 minus 12 is going to be 10. Okay, so that gives me negative 10. 8i plus 3i is 11i. Over, now, 4i minus 4i is gone. It's the whole reason that you end up with 1 plus 16 on the bottom. Why? Because, again, I squared is negative 1, so it changes the sign. Which gives me negative 10 plus 11i over 17. There's nowhere else to reduce that, so I'm going to leave it like that. Now, a couple days ago, we talked about not being able to factor the sum of. Well, it's kind of true, but it's kind of not true at the same time. So when I'm doing this, again, pull the GCF out, that's 2. You end up with x squared plus 16. And this right away should be, well, I can't factor. Well, you can't factor in the world of real numbers, but you can in the world of complex numbers, okay? So again, perfect square, let's take the square root. That's 2 on the outside. Square root of x squared is x. And because it's a plus 16, I need to make that back number 4i. Again, opposite sides. Okay? That exists because when you do the inside, xi, and negative 4ix, or xi, it doesn't really matter, it's going to give you 0xi. Then when you multiply these together, you get negative 16i squared, which then turns to positive 16. So that's how you go ahead and factor out that sum of perfect squares.